So welcome back. Happy Monday. Our ever-dwindling calendar looks like this. Today is our 39th class. We're covering something called the fundamental theorem of calculus. Also today, the final project where you reflect on your work this semester is assigned. It is due at the start of the final exam, which is a week from this coming Wednesday. But you have the tools to do it anytime between now and then, and I'm guessing that you are going to be busier next Tuesday than you are this week. And so I'd encourage you to get it out of the way earlier rather than later. You can throw it in the folders at any day during the semester, but it's due at the start of the final exam. I will hand out our last quest on Wednesday. Wednesday will also be the last day of new material that we cover for the semester. And then Friday and Monday, we've got 2 review days. Any questions on the calendar? That's the official window. We're going to make it 10 to 1, but we'll talk about that next week. 10 to 1 is what it's going to be. Yes?
Are you going to be sad not seeing us for a month?
I'm going to be so sad. So sad. Yeah, I'm already at the beach in my head. Like it's. All right. Okay. 2 other announcements. So first of all, if anybody wants, like in terms of studying for the final exam, like a blank copy of the tests that you took this semester, or a blank copy of the quizzes that you took this semester, I'm happy to print them for you and give them to you this week. So just a quick show of hands. Anybody that wants a blank copy of all the tests and quizzes? 1, 2, 3, 4, 5. Okay, so if the hands change during the count, that sort of makes it difficult. So put your hands up if you're committed to this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. 12. Also, some folks have the habit of registering for the spring semester like over January break, which is okay. The school is open for a bunch of January, and somebody in the advising center will be happy to work with you. However, I would encourage you to get registered for the spring before that, if possible. Number one, the earlier you register, the more likely you are to be able to find open classes that fit exactly your scheduling needs. Also, if you get registered in the next week or so, you can work with your advisor directly, who is probably a faculty member here. But if you wait until January, your advisor might not be in. And so, for example, I'm going to send my advisees an email that says, hey, find me in the next week. Otherwise, I'm not going to talk to you until January 24th. So, so get registered sooner rather than later if you can. Yes?
Registration. If you don't register ahead of time, classes can get canceled and dropped. Get registered.
Yeah, that's a good point, right? Getting registered. I think the bills go out in January sometime, but you'd have to talk to financial aid. You don't pay at that moment. Like you sign up and then the bills get mailed out at some point. Yeah. Okay, so let us jump in here on page 69 with our summary. In this class, we see how to reconstruct a function from its derivative. We also explore something called the fundamental theorem of calculus, part 1. So here is our first example. Let f of t represent the value of a stock market investment t months after January of this year. Then f prime of t represents the rate of change of the value of the investment. Let's go ahead and get the units up here. What would the units be for the rate at which the value of the investment is changing? Dollars per month, that's correct. All right, because this is an input variable with a unit of months, and the value of our investment is most likely measured in dollars, so dollars per month. So let us fill in this table, which has various values of time, these are months, and then the values of the stock market investment at that particular month. It says we're going to assume that f of 0 is 100, meaning when we first purchase whatever stock we're purchasing, it costs us $100, and we're hoping it goes up from there, the value of that investment. And all we are given about the rate at which the investment is changing is this graph right here. This is not f, this is f prime, okay? So take a look at the first month. In this first month, from 0 to 1, we can see that the rate at which the value was changing was $20 per month, and that was positive. And so if the value is changing by $20 per month for a constant during the entire month, then what is the new value at the end of that month? 120. Everybody agree? We just made $20. It's not a percentage, it's a straight dollar amount, dollars per month. And then in month 2, more good news. What do we gain in month 2? It's another $20, and it's easy because it's constant. So that means we're up at 140. Hey, this is fun. Okay, now in the next month, I see what looks like bad news. I see something going down. Are we losing money in that next month? The rate is decreasing, but it is still a positive growth that has happened in that month. And so we want to figure out how much money we have made during this month from 2 to 3. And it's not $20, right? Because we didn't stay constant up here at 20, right? It would have had to do that in order to stay 20. And it's more than $10 because the diagonal line is above the $10 line, right? Do you have a guess what the reality is for how much we exactly gained in that month? It's something between 10 and 20. And because this is a straight line, it's just halfway in between. We gained $15 in that month. But if it were curvy, then all bets are off. And so how are we supposed to do this for real? All right, don't draw this, but suppose that we decided we were going to cut this month into 2 equal pieces, just like we did with the zombies. I'm going to cut it right there. And I'm going to say in the first month, in the first half of the month, let's overestimate and assume we were at $20 a month. And in the second half of the month, let's overestimate and assume we were at 15, just like the zombies, right? And so you could say, hey, $20 a month, but only for half a month. How much money is that? $20 per month, but we only had it for half a month. So that's $10. And then $15 per month, but we only had it for half a month. So that's $7.50. 10 plus $7.50 would be $17.50. But that's an overestimate. How can we get a better estimate? Well, suppose that instead we cut this thing into maybe like 4 pieces, 4 smaller pieces. And we saw last time that what we're really interested is in area under the curve. And so if you just keep, like cutting into smaller and smaller pieces, you eventually hone in on the exact area under this curve. And so the value that we gain, the dollar amount that we gain, is just the area of that thing. That's what we're after. We saw this for the zombie race. The zombie race, we were given the rate of change of distance. We called it velocity. Here we're given the rate of change of value. It is still the same exact principle, even if the words have changed. So what is the area of that trapezoid? Well, it's the area of a square plus the area of a triangle, but however you slice it, you need the area, and the area of that thing is 15. Be careful, it looks like 1.5. That's how many boxes there are, but the boxes are not worth 1, right? So this is really a box of 10, and then a box of 5. So 15, which means the new value is how much? 155. Okay, between month 3 and 4, that is right here. It is the area of that triangle, which is 5, right? So it's half of a box, and every box is $10 in this case. So we just gained another 5, 160. Yeah. So let's take a look at this next month, between month 4 and 5. Can you shade in the area that we are interested in finding? There's one area. It's always the area between the curve and the x-axis. Sometimes that means it's below the curve, but in this case, it means it's above the curve. So don't shade in. Like if you start shading in down here, you're already in trouble, right? It's always between the curve and the axis. So in this case, it is this triangle whose area we are interested in finding. Easiest way to find the area is to figure out what the area of this big rectangle is and then cut it in half. Every square is worth 20, so the rectangle is worth 40. So then our triangle is 20. Okay, so the area of this thing here is 20. So are we up to 180? No. We're down to 140. Because that was below the axis. And so we actually lost $20 that month. We got greedy. Should have sold. Okay, let's take a look at the next month. Oh, this looks even worse. So go ahead and draw in the shape. Draw the shape whose area we want to find between in month 5 to 6. And then we are carefully going to calculate that area. Every square here is 10. So I've got 2 full squares. So that's a 20 there. And then I think that's another, am I wrong? Right, every square is 10. 10, 20. Yep. And then this is another 20 down here. So 40. Did I make a mistake on the last one? 10, 20 should be 10. Oh, 10. Yeah. 10, 10. Sorry. 150. Like I said, each. That's Any mistake from this point forward, Florida is on the brain. Okay, number 6. So, all right, so each box is 10, so that's a 10 and a 20, and then I think that's another 10 for this triangle because that's the same triangle. It was in black over there. 10, 20, 30 is what we lose. So we're down to 120. Okay, and then in the last month, it's the worst of all the months that we had. It is this big fat rectangle. How much did we lose? 40, leaving us with 80. Yikes. Yeah. So not only have we lost all of our profits, we actually lost some of the principal. Yeah, it's too bad. Okay, so let's move down to number 3. So pretty straightforward. You just have to calculate areas, but we're going to make a more general observation here. Like I said, the zombie race, we were given the velocities and we were interested in area under the curve. Here we were given the rate at which our value was changing and we wanted the area under the curve. This is something that is more general. So here we go. Number 3, as we've just seen, the area between the derivative, that was the picture, and the t-axis represents the change in value of the investment over the course of the 7 months. Let's see if we buy that. Suppose that we were interested in not all of these numbers here, but just the last number. We'd be interested in finding the area of this whole thing here and this whole thing here, yeah? So let's really quickly just get that one single number. Every box is 10, 10, 20, 30, 40, 50, that's a 55, and a 60. Remember with me? We gained 60. Do you see the gaining 60 anywhere as a single number? There it is right there. Didn't we gain 60? Right, and then we start losing stuff. So I'm going to start with the 60 that we had, and then we lose area. So that was at minus 10. So now we're at 50. That was a minus 20, 30. So 50 minus 30. Now we're at positive 20, and then we just lost 40 there, and it's a negative 20 altogether. I think when all was said and done, that was a 60 up there and a negative 80 down there. And so the net was negative 20. Do you see that negative 20 between the first number and the last number? 100 to 80. We lost 20, okay? So let's see if we can write all that in symbols. Here it is. We represent the area with a definite integral from 0 to 7, f prime of t dt. That's the whole thing. I'm just going to write the final answer here. That turned out to be negative 20. Our signed area, right? We can represent the change in value of the investment over the entire 7 months as f of 0 minus f of 7 minus f of 0. What was f of 7? 80. What was f of 0? 100. And of course, it's the same negative 20. So the point is that if you do that integral of the derivative, you will get exactly the same thing as the final value minus the initial value for the original function, right? Those two negative 20s are exactly the same. There's nothing special about this particular picture, always going to be exactly the same. So putting it all together, we have the following. Integral 0 to 7 f prime of t dt, that's the area, is final value minus original value for the original function. That's this thing right here. And all we're gonna do is change the 0 and 7 to say, hey, this is true for any set of numbers in any picture that you want. And here it is. It is called the Fundamental Theorem of Calculus Part 1, FTC1. If f prime is a continuous function on a closed interval AB, then that equation right there is just a carbon copy of the one we saw before, but instead of 0 and 7 specific numbers, we just make it general A and B, any input numbers you want. And like I said, it's called the Fundamental Theorem of Calculus. So here it is in bold. The area under a derivative gives the actual change in the value of the original. The area under the derivative is the change in the original. The area under the velocity was the change in position. The area under this derivative for stock market value is the change in actual stock market value. One of them is a derivative, one of them is the original. Okay, important fact, the units for this integral, f prime of t dt, which is the integral we're focused on here, are the product of the f prime units and the t units, which kind of makes a lot of sense, I think. Because after all, we are multiplying f prime by dt. We just have to multiply those units to get the units for the final answer. So for example, thinking about, in our case, let's do this one here. What were the units for time in the stock market example? This was months. What were the units for f prime? Dollars per month. And what do we get when we clean up these units? Dollars. Which makes sense. That integral represented a dollar amount, the change of $20, negative $20. So anytime you're faced with an integral and you want to know what the units are, you just multiply the units of the two things, the thing you're integrating and then the independent variable itself. Okay, number 6, the rate of flow through a pipe. It's given by this formula, f prime of t. Notice it's a prime. I'm telling you a flow rate, a rate at which the oil is changing. It's flowing through a pipe. It's given by t times 2 plus sine of t over 3 plus t. That is gallons per minute at time t. T is minutes from whenever we start the experiment. Let's use technology to find the amount of oil passing through the pipe in the first 20 minutes. Let's give this a shot. Okay, we are given information about the derivative. We want information about the original. We're going to use our brand new formula up there, fundamental theorem of calculus, right here. So, integral. A and B are the specific input numbers. They're given in the problem. What are they? 0 to 20. It's the first 20 minutes that we care about. So we put a 0 and we put a 20. And then the next thing we're supposed to write is f prime of t, but it happens that we have a formula. So how about we write that instead of writing f prime of t? So we go t, 2 plus sine t over 3 plus t. There's something really important we need to put before the equal sign. It's part of every integral that you write is a d something. It's dt in this case. Every integral symbol has to have a corresponding d something. It's notation, but it's important. Okay, and according to our fundamental theorem, that left-hand side is supposed to equal f of the top number minus f of the bottom number. So I'm just going to write f of 20 minus f of 0. It's always in that order, top number minus bottom number. Notice that those are f's, not f primes. Also notice that I don't have a formula for f. In fact, I really hardly know anything about f. I'm going to get some information right now about f. So the integral on the left-hand side, like I said, we're going to use technology. You don't need to do this right now. So just have a look. So I'm going to go in and calculate this integral. There's the way to do it on the main screen. Math 9 is this FNINT, and then you can type stuff. But I'd rather see the visual. So let's type that function in here. So we go x parentheses 2 plus sine x, close, divided by, careful with extra parentheses here, 3 plus x, okay? You don't need parentheses around that x, but it's not a bad idea to put it. Yeah, we don't, but you can put it, it's not wrong. Okay, so, wait, close, yeah, we're good. Okay, so that's fine there. Let's pick the window. X min is given, what is it? 0, X max is given. 20. Okay, the y's actually not 100%. I do know that if I plug 0 in here, I get 0. And if I plug 20 in, I don't know, I get something over 23. It's probably not that big. I'm just going to go up to 5 and see what happens. I don't know exactly how big it goes. Let's try 0 to 5, something like that. If we need to adjust it, we will. Also, because my function involves a trig, I need to go in here. This is no good. It needs to be radians. Anytime you hit one of those 3 buttons, you got to think about what mode you're in. Okay, so I think we're good. Let's graph this thing. Okay, so this is the first 20 minutes. So first of all, we are interested in the area under this curve. The fact that this function is entirely positive the whole time means the oil is only flowing one direction. It's not flowing and then going the other direction. Also, generally speaking, is the oil flowing faster or slower as time passes? Generally speaking. Generally faster, but for sure it is both. It's speeding up and then it's slowing down, and it's speeding up and it's slowing down, but it's not slowing down to as slow as it was before. So generally this upward trend. And then we know that we can go into second calc and ask for the integral, number 7. and it says lower limit and you hit 0, and it says upper limit and you hit 20. And because oil is black, it's going to shade it in for us in the right color so you can see it, really visualize it. And then it's going to give us one number right over here, 27.55. That's how much oil has passed through this pipe, 27.55. So from the calculator, $27.55. Let's get some units. What are the units? So I said it's the F prime units times the T units. What were the units for F prime? That's gallons per minute. But continuing on, it's F prime units times T units. What are the units for T? Minutes. And so ultimately, just gallons, which makes sense to us, 27.55 gallons. What does that have to do with the right-hand side? Well, the right-hand side says F of 0, that's however much oil has flown through the pipe until we started the experiment. And then subtract that from F of 20, which is how much oil has flowed through the pipe up to 20 minutes in. And the difference is the actual amount of oil that flowed through the pipe in those 20 minutes. I don't know what happened before we started the clock at 0, but I can tell you for sure in those 20 minutes, 27.55 gallons of oil passed through this pipe. Make sense? Okay. All right, so the activity is here.